Welcome! In this video, I'd like to show how to solve logarithmic equations. If both sides of the same base of the logarithms, one method to solving logarithmic equations is by setting the argument part of both sides of the equation equal to each other. We begin by isolating the logarithm of the same base on each side of the equation. Then equate the argument of logarithm. In other words, we simply drop the logarithms. Finally, solve for x. However, please check the solutions since there are no logarithm of negative numbers. If you do not see logarithms on both sides of the equation, then we need to use another method. Step 1. Isolate the logarithm on one side of the equation using the properties of logarithms. Step 2. Convert the logarithms into exponential form. If we have the natural log, we use base e. For log, we use base 10. Step 3. Then solve for x to get the solution. Again, please check the solutions since the argument of logarithm must be positive. Let's start with the first example. First, we need to isolate the logarithm of the same base on each side of the equation. To do so, move the second term to the right side. For this question, we can see the logarithm with the same base on each side. Then we need to equate the argument of logarithms. Just simply drop the logarithms and set the argument equal to each other. Now we can solve the equation. Move the x term to the left and the constant term to the right. Simplify the equation as negative 4x equal to negative 7. Finally, we divide both sides by negative 4 to get x equaled 7/4. Let's check our solution using the original equation. Substitute the solution 7/4 into each x. We can see the argument of logarithm are positive, and the 7/4 satisfy the equation. Therefore, the solution is 7/4. For b, first we need to isolate the logarithm of the same base on each side of the equation. To do so, move the second term to the right side. Now we can see the logarithm with the same base on each side. However, we can see the coefficient of 2 on the right side of logarithm. So let's rewrite it using the power of log property. Simplify the right side. Then equate the argument of logarithms. Again, simply drop the logarithms and set the argument equal to each other. Now we can solve the equation next. Step 3. Solve for x then. Move the x term to the left and constant term to the right. Simplify the equation as negative 2x equals 18. Finally, we divide both sides by negative 2 to get x equals negative 9. Let's now check the solution using our original equation. We can do this by substituting the solution -9 into each x. We can see the argument of logarithms are both positive and -9 satisfy the equation. Therefore, the solution is -9. Let's try another example. We need to isolate the logarithm on each side of the equation. To do so, we rewrite the left side using the quotient rule of log property. It can be written as the quotient as shown using the property. Now we can see the logarithm with the same base on each side. Equate the argument to each other. Simply drop the logarithms from both sides. Now let's solve the equation. First, multiply both sides by denominator 6 minus x to get 8 equal x bracket 6 minus x. Distribute x to the inside of the bracket on the right side. This is a quadratic equation, so we should get 0 on one side of the equation. The left side function can be factored as shown. Let each factor be 0 to get x equal 2 or 4. Again, we should check the solutions using the original equation. First, substitute one of the solutions 2 into each x. We can see the argument of logarithms are both positive. Similarly, substitute the other solution 4 into each x. Both arguments are positive as well, and both 2 and 4 satisfy the equation. Therefore, the solutions are 2 and 4. Let's move on to another example. This equation has a logarithm on the left, but the other side is a constant. So the first step is already checked. For step 2, convert the logarithm into exponential form. Take the base to the power on the other side. Then that answer should be equal to the argument x on the same side. Note that the base b is always positive and it is not 1. Using the conversion rule, let's rewrite the given logarithm in exponential form then. We have base 7 to raise the power 2, which is equals to x. Solve the resulting equation to get x equal 49. Again, we can check the solution to make sure we have a positive logarithm using the original equation. It is indeed positive, so the solution is x equals 49. Let's solve one more example. We can see two logarithms and the constant terms. First, we need to isolate the logarithms on one side. So we move the logarithm from the left and keep the constant 1 on the right side. Since we have two terms of logarithms on the left, let's combine them using the product rule from our log properties. Using this property, we get log of x bracket x plus 3 on the left. Now we have one term of logarithm on the left We can convert it into exponential form next. Take the base 10 to the power 1 on the other side, then that answer should be equal to x bracket x plus 3 on the same side. Simplify the expression to get x bracket x plus 3 equals 10. In the last step, we can finally solve for x. Let's distribute x to the inside of the bracket. It looks like a quadratic equation now, so we move the constant 10 to the left to get 0 on the right side of the equation. Since we have trinomials, let's factor it as bracket x plus 5 bracket x minus 2 equals 0. If you need more practice on factoring, please watch another video called Factoring, linked in the description below. Set each bracket equals to 0 to get the two roots as x equals -5 and 2. Let's check the solutions using the original equation. Substitute -5 into each x. As you can see, the argument of the logarithm are negative, so this is not the solution. We can substitute another solution x equals 2 this time. Here, we can see that both arguments are positive. Therefore, the solution is only x equals 2. I hope this video has helped in your understanding of solving logarithmic equations. If you have any questions, please post in the comments below. Thank you for watching. See you next time.